electronic mail security. In electronic mail security, there are different things. There are some basics which we are required to study. So first is digital signature that we are going to study, and then we are going to learn about the PGP and other algorithms. So first here we are going to learn about the electronic mail security digital signature, which is basic and which we are not covered previously. So that we are going to cover first. So see, basically we again learn different algorithms like crypto algorithms, which again to protect the security. There are different crypto algorithms like AES, DAS, RSA, different algorithms which we have studied. The second algorithm is like key exchange algorithms, like Diffie-Hellman kind of algorithm, which we have studied previously. And again, we are going to study some authentication algorithm, which again comes into this digital signature comes into this authentication algorithm. So what is digital signature? That we are going to study first, and then we'll see the different algorithm which can implement it with the digital signature. So the digital signature is a mathematical scheme that is used to authenticate the sender of the electronic document. A digital signature is nothing but attach of any piece of electronic information which represent the content of the document and identify the owner of that document uniquely. So you just have to find out who is going to send the message and who is the sender. You just have to authenticate the sender. So how we are going to authenticate the sender? So using digital signature. There are like again physical signature you must have seen on the different document, different check, bank checks are there. So using that you can authenticate that person that he signed on that particular document. So you can again identify that person. So like this here, there are some digital signature. Using the digital signature, we can authenticate the sender of that message, who is again sending that message. The basic thing is the message or the hash code, which is encrypted with the sender private key, that we can call as a again digital signature. So the there are different things which we saw previously. Okay, so the I just remind you. So there are again the symmetric and asymmetric kind of thing. Okay, so the symmetric thing, symmetric approach and asymmetric approach is there. In symmetric, what is that? So there is again only the one private key is shared between two users when they are again communicating with each other. And in a symmetric algorithm where there are different two keys are there, the private and public. The public key which is available to all, and the private key which is again available to that particular user only. Okay, so that what is to have. And again the public key can be accessed, and that can be again used for the encryption, and at the receiver end the receiver is to again use his private key to decrypt that message. Here some kind of thing is why again repeating. So here again we are going to have the digital signal approaches. Okay, so there are two different approaches which we are going to study. So first is RSA approach, and second is digital signature standard, which is DSS. Okay, so these are the different approaches which we are going to study. So how it is again implemented. So here these are some block diagrams which we are going to take. So this is what the simple plain message. This is a simple plain message which is sent by user A. Okay, and this which we require to authenticate, that A is only sending the this message. So how we are going to again authenticate this thing using RSA. You know RSA algorithm. So here we are going to use the RSA. I'm not again explaining whole RSA algorithm because we again learned this RSA algorithm before. So this is what the message is there. Now this message is again implemented a hash function of this message. Okay, though there are different again hashing functions which we have studied. Okay, MD5, MD3, MD2, like SHA is one of the thing. Here we are using SHA. Okay, so this message is again encrypted or hash implemented on this particular message, and then SHA algorithm which is used, and then this can be encrypted. Okay, the hashing, what we are going to get from this, the message plain text, okay, which we are going to again implement hash on that plain text. Then that plain text we are going to encrypt. Okay, how we are going to encrypt? So in again as I told you, there is again we are using a symmetric approach over here. So there is a public and private key. Okay, in RSA, you know how to generate using P, and in Q we used to take prime number and all those things. So here we are going to take a private key. Okay, this private key, using this private key we are going to encrypt the Message is what? The hash key. Okay, the message we are again, the hashing function is what it does. So it again creates some unique key, okay, for the given message. So like in it used to create some 128-bit key, or again depends on the algorithm, it again create unique key. Okay, so that unique key we are going to encrypt with the private key, and this encrypted message plus the simple plain message we are going to append, and we are going to send at the receiver end. In the receiver end, what the receiver is going to get? The message and the key, encrypted message, which again contain the hash key. Okay, now what we are going to do? We require to authenticate that this A is only sending this message. So how we are going to authenticate? So here the hash key is there, which is encrypted, and this hash key we are going to decrypt. Okay, how we are going to decrypt this hash key? Here we required private key, as we are again asymmetric approach we are using. So here this is what the private key. So here we are using public key. Using this public key, what we are going to do? We are going to decrypt the message, and what we are going to get is a hashing key over here. And again, same thing, what we are implementing over here, same algorithm we are implementing for this message, and we are implementing hash algorithm for this particular message, and again we are going to get one hash key. So here again we are going to get one hash key. From here again we are going to get one hash key. We are going to compare those hash keys. If those hash keys are again same, then we can say this message is sent by A only. So this is the authentication, how we used to authenticate this message. Okay, so this is how the RSA approach we used to call, because here basically what happened here, this is what the when we are encrypting the message, so using private key, which again we used to create private and public key using RSA, and then this private key we used to encrypt, and for the decryption again we are using the public key. So this is what the RSA approach. Now we are going to see the second approach, which is digital signature standards. In digital signature standards, there is again we are going to take a plain text. After plain text, we are going to again implement hashing. Again here we are using SHA-1 or SHA-5 hashing algorithms to again generate a unique key. So here that unique key is given to this signature function. Okay, now I am going to tell you in next slides what is a signature function, what it does, and what are the different formulas we required for the signature function. Okay, so here this is the signature function. The hash key which is generated from the message is given to the signature function. There's a k, which is again one of the random variable which we used to create, which we are going to give to the signature function. Okay, now this is the PUG. Now what is PUG? This is the global public key component. This what we used to call as a PUG is global public key component. Okay, so that what we used to call as a PUG, that we require to calculate. How we used to calculate this thing, that I'm going to tell into next slides. Okay, so next slides we are going to see how to calculate PUG. This is a private key, okay, which again we are going to give for the signature function. Okay, so what signature function input is? The hash code, the random again variable which is k, then this is the global public key component, that is PUG, and this is a private key of A, who is sending the message, that is A, and his private key which we are going to give to the signature function. Now what is output of the signature function? So this is the output of the signature function, the message, plain message text, then SNR. So what is SNR? That I'm again going to explain. Okay, so this is what the signature function. Then this signature function we are going to append with the message, and we are going to get the message S and R uh, uh, functions, which are the output of signature functions, and which again receiver is going to get this thing. Okay, receiver is going to get is M, S, and R. So this M and S and R, when this receiver is going to get, at that time M is again hashed. Okay, again the same hash algorithm which is used over here, same hash algorithm can be implemented to this message which receiver is going to get, and then it is going to be given to the verification function. Here this we used to call as a verification function, and there is a S and R. These are the again generated by the signature function, that again going to we are going to give as an input for the verification function. And the verification function again use the key, which is a global public key component. This is a global key public key component. In both sides we are using global key component, okay, global public key component. And here we are using a where we are using a public key. Okay, here we use for encryption a private key. Here for decryption again we are using public key. So global key component plus public key we are using for the verification function. So this is the input for the verification function, and we are going to compare the output of the verification function with the R. R is generated by a signature function. Okay, so we are going to again compare verification function output with the given R. So I'm going to tell you what is signature, how the signature function works, how to calculate the global public key component, how to calculate private key, how to calculate again the public key and private key. Okay, and how the verification function works, and what is S and what is R. Okay, so here the calculation of global public key component is, okay, it is G is equal to H P raised to minus 1 by Q mod P. Okay, so here, okay, so here mod P. So basically what we are going to do is we are going to calculate uh, global public key component. So H is any integer. Okay, H is any integer which we require to calculate. Now, what is H resides between 1 to P minus 1. Okay, and we are going to calculate the private key. Uh, okay, we are going to calculate private key also. So this is how used to calculate global public key component. So P we are going to take as a random number. We are there is a prime number, okay, that we are going to take. So see, basically P is again the prime number that we are going to see in next slide. Okay, so first the G is what, the H is any integer we are going to take. So H raised to P minus 1 by Q mod P. Okay, H is any integer. H resides into 1 minus 1 and P minus 1. Then again, here we require to calculate the private key. Okay, so the private key is how we are going to calculate. So we are going to take X as any random number. X is going to reside between 0 to Q. Okay, so that what we, how we are going to calculate the private key. So here digital signatures in that there is a public key component, how we are going to calculate P and Q. Okay, so which again I forgot to mention that P and Q. So as RSA works like this, again we are going to take P as a prime number. Okay, how we are going to calculate the global public key, whether P is a prime number, then Q as a prime divisor of P minus 1. Okay, so Q is a prime divisor of P minus 1. So if P we are going to take as a prime number, we are going to take as 11, then Q will be prime divisor of 10. So what is the prime divisor of 10? As we have seen in RSA, so that will be, Q can be 5. Okay, so the Q will be 5 and the P will be 11. Okay, so that how it works. And using that, again, we are going to calculate the global public key component, where G is equal to, now we have taken P and Q. So G is equal to H is any integer we are going to take. P we are taken minus 1 by Q mod P we have to take. So we are going to calculate G. G is what? Again, G is this. G is the global public key component. This is what the global key public key component where we required in both sides. This is global public key component. Okay, so that we are calculate using this formula. Now there is a public key. Okay, now public key, where we required public key. So here we required, we again calculated private key. Now here we required a public key. This is what where we required in verification function we required a public key. Okay, so how to calculate public key? So the formula of public key is y is equal to G raised to X mod P. Now again you can see here we calculated G. Okay, so here G raised to X. X is what? The private key mod P, where G is a global public key component. P is a prime number, which we are again, derived first at the start of the algorithm, and then X is a private key. Okay, and the K resides between 1 to Q. Okay. Mm. Okay. Now here the digital signature standard. Okay, now see here we again derived all those things. Okay, public key, again the public key component we are derived, private key we derived, and again the public key and private key and the global public key which we are derived. Now here what we have to check is the signature function. This is what the signature function. How we are going to calculate the signature function, that we are going to check. So here signature component. What signature component again produce? R and S. Okay, what the signature component produce is R and S. This is how it works here. The signature component produce with append of the message, it produce S and R. So what is S and R and how to calculate S and R? So R is calculated by G raised to K. Now G is again global public key component which we have calculated. K is a random number mod P mod Q. So that what we should call as a R. How we are going to calculate R. And this is what the S is. S is what? The K raised to K raised to minus 1 uh, message which we are getting, that we are going to again hash, implementing hash plus X is a private key into R which we are going to get from here. Okay, this is how we are getting R. So this how we are getting S mod Q. Okay, so this is what the mod Q, and we are getting R and S, and this is what the signature function. So signature function gives you S and R. Okay, now after signature function, what is going to happen? So see, this is again the message append with hashing key which is given to the signature function. This is the global public key component with a private key which is appended with the message, which is again produce message S and R. How again we are calculated, or the global public key component, private key, public key, and SNR. Okay, now this which is received at the end of verification function. And in verification function, what is going to happen? So here in a receiver, the receiver end, the verification function we will be calculated are first it will calculate it and then it will be compared with the R. Okay, so here again which we have seen in this particular diagram, that this what we are going to get, then this the message which is again implemented by hash function S and R given to the verification function with the global public key and the public key, regular public key, which is again we calculated and which is given to the verification function. The output of verification function is compare with only R, and this comparison, if the keys are same, then only we can say the message is authenticated from the user or not. Okay, so that we are going to check. So how the verification function works? So here V, the verification function is G raised to U1 into Y raised to U2 mod P mod Q. So what is U1? Okay, so G is, you know what is G? It is global public key component. Y is what? It is a public key. Okay, and mod P and Q, you know what, how we derived. So here U1. So in U1, what happened? So how we are going to calculate U1? So there is a message which we are going to get from the receiver, which is a plain message, sender, which we are going to get from the sender. So that message we are going to again implementing hash function into W mod Q. Okay, so U1 is hash function implemented to M into W mod Q. Now what is W? So W is S inverse. Okay, now what is S? So again S we are again calculated over here. See, RNS. Okay, so S we are getting in signature component. So that S we are going to put over here S inverse mod Q, which is W. So W which we are going to put over here hash message into W mod Q. So that is U1. What is U2? U2 is R. R again we are getting from digital signature standard. So this is R. So this R we are going to calculate in R into W mod Q. So this is U2. Okay, so this is G. G is what? The global public key component raised to U1. U1 is this into private, public key, which is Y, raised to U2. This is U2 and mod P mod Q. Okay, so this what we are going to get as a V. So when we are going to get V by calculating all those things, so this is what the V. Okay, so verification function, we are going to get output from the V, and then there is R which we are calculated. So R and V, what we are getting from the V should again equal. If they are equal, we can say this is the authenticated. Okay, so this is how the digital signature standard algorithm works. Okay, these are some applications: electronic mail, data storage, electronic fund transfer, software distribution, smart cards, ISDN, timestamp signature, blind signature, these kind of things where we required this digital signature. See, basically these digital signature works at the back end. So there is a transparency. Any different application having different kind of digital signature, strategies. But again, the end user cannot see these things are at the back end. The transparency is maintained, so you cannot see all those things. But at the back end, everything is going to work. Okay, so these are the things application where the electronic mail, data storage, and electronic fund transfer, smart card, where it is used. Now in next lecture we are going to check the PGP, okay, which is based on this only. So this is what the uh, digital signature, where we will learn different things today. The things are RSA and digital signature standards. Okay, if you have any doubts, any difficulties, please you can mail or you can message. Now the question is, why are digital signature considered secure? Digital signature work using a public key cryptography, and the public key cryptography is a cryptographic method that uses a key pair system, private and public. The private key encrypts the data, and it's available only for the signer, and the public key decrypts the data pertaining to the digital document, and it is given to the receiver. However, both parties must have registered digital certificate from the issuing certificate authority to connect the signer and the signature. The public key cryptography ensures that the security, accuracy, and authenticity of the document. Encryption is the process of encoding data sent to the receiver in the form of that can only be decoded by the receiver. Authentication is a process of validating the information from the sender to genuine and has not altered in a transit. Just like each handwritten signature are unique, and every signer is again given a unique digital identity from the trusted service provider. When the signer signs the document, the signer identity is validated and the signature is encrypted using a public key infrastructure technology. Now, when we are talking about again, there are different authorities are there who are again giving you the digital signature. One of the again certificate authority who are trusted service provider, that is TSP, provides digital certificates to ensure that the key generated and documented signed are created in a secure environment. Where the digital signature helps to validate the holder of certificate, digital certificate contain a public key, as we have seen previously, of the sender and digitally signed by the certificate authority. There is a public key infrastructure, that is what we call the PKI, and it includes the regulation, protocols, rules, people, and the system that aid the distribution of public keys and the identity validation of the users, which digital certificates and the certificate authority. There are different benefits when we are talking about the digital key, digital signatures, and which again digital signature having a caught of the fancy of many corporates and executives what exactly it is. And simply put, when we are talking about a digital signature, it's electronic fingerprint, and it let you sign a document electronically, and it validate the signer. It is a mathematical code, as we have seen, that authenticates the document from the sender and ensure the document remain unaltered on reaching at the recipient side. And it the fears about the security of digital signature is reasonable. However, it uses accept format called a public infrastructure, that is PKI, and which provides a very high level security, making it difficult for duplication. And digital signature makes office paperwork far more efficient. But laws regarding this technology as very varies in different countries, country wise. And the benefit of the digital signature have more, the it's more for the offices and companies getting the for the e-signature, making more efficient and secure workplace in digital format. So when we are talking about the advantages of digital signature, it basically saves this time. longer have to wait for your manager to return from the holiday, and again for waiting for the sign of the conferences for for the signatures. That is not again required, where the digital signature ensures that the business save the cost and time with the documentation, contract sign off with click of button. There are huge saving in the cost and time, especially when the person required to sign in a geographically different areas. Document can be signed off almost instantly from anywhere, and it be the the on it can be on the tablet, phone, or computer. Digital signature can be and seamlessly ensure that the otherwise, otherwise it will be again the tremendous task when we required the physical sign. It is again basically this cost saving. Many companies also see the significant cost saving with the title or no expenses in a link, and paper, printing, scanning, shipping, delivering, travel expenses. There are also saving in another indirect cost, which is again filling or rekeying data, archiving, and tracking. That is again we can achieve the workflow efficiency, which lesser delays. Digital signature ensures better efficiency in overflow. Managing a tracking document are made easier with less effort and time involved. Many features of the digital signature help speed up the work process. For instance, like email notification helps remind the person to sign, while status tracking or the help to know which stage of document it is. Yeah, so there is again better customer experience you are getting. And the thing which is very important is security. When it comes about the digital signature, authenticity and the security is a priority. Digital signature reduce a risk of duplication or alternation of document itself, and digital signature ensures that the signature is verified, authenticate, and legitimate. The signer is provided with the pins, passwords, and codes that can again authenticate and verify their identity and approve their signatures. Time stamping provides the date and time and the signature, and this provide a track of document and minimizing the risk of tampering and or you can say the fraud. Security features embedded in a digital signature ensures that the document have not been altered without authorization. So that is again the legal validity you can have for that particular document. And there is again environmental benefits are there. There are business efficiency can be increased. So these are some advantages of digital signature. Thank you.